All right, so what I want to do is step you through the design and construction process. Now, obviously, we're not going to spend time talking about how to design and construct these projects per se. What I want to do is give you the steps that we went through. So step one for us, because my primary responsibility is to get the channels in the Atlantic coastal zone clear of sediments so that they can be used for navigation. Our first step was to find some material in this area that could be used to both, clear the channels and help Virginia with her marsh restoration. So we identified 4 channels in the nearby area, about 1.6 miles of the 200 nautical miles that I'm responsible for. We identified about 6,700 cubic yards of coarse grain material and about an equal amount of fine grain material. And one of the challenges in this area is that there are no available sites. So, whereas in other parts of the state, we might have confined disposal areas or beach placement areas that we've identified and used over time, there were no areas in close proximity to these sites. So they were what we call orphaned or abandoned sites. We couldn't do any dredging until we found a partner who wanted the material. Okay, so as Virginia pointed out, this is the marsh, and we spent a lot of time working with Fish and Wildlife Service and the other project partners to look at this site and to evaluate what we could do on the site. It is 17.5 acres, and what was decided was that a target elevation of 0.7 feet. Now, let me just say something about elevations, because this is important. The more elevation that you need to add, the easier it is. Now, I realize that nobody wants to bury the existing marsh, neither do we. However, putting a couple of inches over 37 acres or 47 acres or whatever is practically impossible to do. So what we need to do is to come up with a practical solution that would allow us to place material and take advantage of the site and its characteristics, such that the material would actually go onto the site and stay on the site. And we needed enough capacity to make the project work, but also have the type of materials that would flow easily onto the site. All of that had to be evaluated. So in some cases, I think the bottom line here is sort of think of this as a mud floor. You've got a lot of contours across the site. You've got deep places. Maybe there's some mosquito ditches, some drainage ditches, some salt pans. There's also high areas. There even might be areas that are man-made high. When the Mosquito Commission goes in and puts in ditches, they might be berms. So there's a lot of topography here. What we're seeking to create is a natural marsh ecosystem, which has natural marsh hydrology. So the idea here is to be able to go in and place material in a practical manner that will allow us to get to that target hydrology. Bottom line for this site, 0.7 feet was what we were targeting as sort of the baseline elevation. And then that gave us about 10,200 yards of capacity. Now, that number doesn't mean a whole lot. And in fact, most of these projects aren't, because you can't practically get out there and survey everything. So there's a consolidation factor that over time, these sites are going to probably sink as you add material onto them somewhat. The material will consolidate and the underlying material may consolidate, especially if it's a weak platform. So there's a lot of aspects of this. Now, I know Genevieve said like on like. One of the things I will say about that is that the jury is still out on like when it comes to material types. There may be some situations where sand is desirable in certain parts of a restoration and fine grain material is desirable in others. Obviously, sand's going to pile up and it's going to consolidate. Fine grain material is going to tend to flow out. So maybe different objectives for different parts, something we're still working on. As Virginia said, we didn't know a lot back then. We know a lot more now. Okay, so as I said, we had some coarse grain material and some fine grain material. And at this point in time, we thought that only fine grain material could go on the marsh. And certainly with a very small target elevation, fine grain material made more sense than a lot of coarse grain material, which meant that, but I had coarse grain material that I needed to move. So what I needed to do was to find what other parts of this ecosystem could benefit from some coarse grain material. And what we decided is the leading edge of the marsh actually had a historic sort of a ribbon beach along the marsh edge, not a bathing beach, but wildlife utilized it quite a bit, and shore nesting birds utilized these sand strips quite extensively. Plus, there's been erosion problems on all of these marshes caused by increased sea level rise and wave action. And so what we wanted to do was to say, could we use some of this coarse grain material to reinforce that natural beach and possibly retard some of the erosion, create a little overwash area, and create some habitat for beach nesting birds. So what we did is we designed a berm that would be placed, so we would just pump material into the near shore. And rather than a traditional beach placement where you put heavy equipment on the beach and push it around to make a nice, picnic beach, we were going to allow Mother Nature to move that material into a natural position against the existing remaining beach. Now, one thing before we move into construction, the last thing, and this has become much more important, we've realized how important this is going forward for the design, and that's a hydraulic analysis. If you want these marshes to behave normally, what you want is them to have normal hydrology. Over time, almost all of New Jersey's marshes have been affected by mosquito ditching and impoundments and other types of man activities over the years, and so they don't have normal hydrology. This site was burdened by two things. Number one, it had been extensively modified and drained, and also it's micro-tidal, which means that there's not, up in this part of Barnegat Bay, there's not a lot of tidal cycle. So both of those things challenge this site. We like to have a lot, over a foot of tide really helps to move the material around on the marsh as you're constructing, and microtides have a problem. This site also was impounded all the way around the outside by the road and a berm, which made it not drain very well. And I just want to show you some of the, I don't know if I can activate this. I'm not going to be able to activate. Did I do that? Adriana?
No, that was me. Hold on.
Okay, see if you can activate that model run.
Yep.
I just want to show you what the site was, how the site was draining, filling and draining on a normal tidal cycle before we did our construction.
Yeah, I have to get rid of this. Oh, can I move this thing? Oh, I can move it. I'm so sorry, people. All right. So is it going now, Scott? Carry on.
Yep, it's going. So you're watching the site drain right now. Pay attention to that upper right hand, the right hand side. You can see it. Is it running? No, you paused it. Run it. Yep. Is it running? There it goes. So you can see the site is draining back to the right, which is to the east. Now it's stopped. That's about as much drainage as you get on a normal tidal cycle. You'd have to have a number of really low flow or wind-blown days in order to get that site to drain. So this is not good for a marsh, as we all know. So if we were able to get material placed in all the areas and to reestablish a stable marsh platform, the right-hand side is what we were hoping to achieve. So go ahead and run that model. Magic. Those upper right hands that are still blue weren't targeted for placement. So what we were able to show is that if we could get to where we wanted to be, in other words, if the material behaved the way we wanted to, we had enough material and we achieved our targeted elevation across the whole site, the site would behave normally hydrologically, which is the desirable outcome. So every time you're doing one of these projects, this is an important step, is to understand how the hydrology is behaving now and what it's going to do when you start placing material. Next slide. You can go ahead, or can I control them now? Okay.
Yep, I relinquished control.
Yep. Okay. So we went ahead. We got our permits. We went out and contracted with H&L Contracting out of New York. They brought their 10-inch cutter head down and a 1,600 horsepower booster pump and 10,000 feet of hydraulic pipeline, which I have to tell you is a large amount of plant for a very small project. But we wanted to make this project happen. Let's talk about the shoreline stuff first. We pumped 6,000 cubic yards of sand from 3 of those 4 channels over 11 days and placed it in the near shore right up next to it. We used what's called a spill barge. So that bunch of equipment that you see there is essentially just a platform, a movable platform for the pipe, which allowed us to spray right up next to the beach. And you can see in the foreground of that top left picture how the material, once it settles out, integrates nicely into the existing beach. We placed that material along 1,700 linear feet of marsh. For the enhancement, another 6,000 yards of mixed, and it was pretty mixed. I would say there was fine sand and silt. I wouldn't call it, like, it wasn't like 20% sand. It was more like 40% sand, but a fine grained sand. And we placed that in the marsh. We ran a single pipeline from the bay, had to run it underneath Bayview Avenue and out onto the marsh. And then we put a marsh excavator out there that is actually an excavator that is capable of floating. So you can actually run it through deeper water and get it out onto the marsh, and then used it to move the pipeline around to direct the material. We also, and we placed that material over 9 days on about 5.5 acres of the marsh. We used about 1,000 feet of compost-filled filter socks to block off the channels and to hold the fine grain material in, and to try to get some filling of those channels. So that's what I have for construction, and I'm sure we're going to hear from Dan to talk about some of what we saw, and Joe is going to talk about some of what we saw. So I'll relinquish slides now.
Thank you. Oh, I can actually control the slides. Cool. Hi, everybody. So I'm just going to talk for a few minutes regarding the monitoring effort along the nearshore placement, not on the marsh placement. Cool. Little lag. So you've heard about the project site, so I don't need to go into that. The sandy shoreline has been migrating landward, threatening the marsh area. It's a narrow sandy estuarine beach with a dune system, and it fronts this tidal marsh at the corner there at the south end of the Toms River there. You've seen the nearshore berm linear bar placement plan. And with the hydraulic placement, they attempted to achieve this design. So they did about 6,000 yards, as Scott had said, 70% sand. It was hydraulically dredged from these channels that are highlighted in blue. So our preliminary results regarding the placement of the material was, so our original monitoring effort included surveys before the placement, immediately following the placement in January 2021, and then 3 month, 6 month, 12 month, and then we have one more coming up in April. Now, in addition to that, we also monitored the active placement using drones, but we also did some deployments of Turner C3s for turbidity, but also an ADCP to identify the currents and waves in the area. The final piece of this monitoring effort, we're actually doing some modeling right now. I actually have the model running in Delta 3D right now. identifying different configuration options for future placements. One of the things we found is the sediment transport is predominantly to the south here. And what we found was over the 12-month period, the majority of the material that was placed, about 42% remains after 12 months. And it's predominantly in this southern section right here. And we saw that actually during the placement as well. The currents were so strong coming out of the river that a lot of the material had wound up in this little corner here. The rest was either lost to the offshore or overwashed during an event on December 25th. So as you can see here, it was kind of astounding before and after dredge. There was a storm right in between the placement in December 2020. So the offshore portion actually lost quite a bit of material, but the nearshore berm retained some of the material that was placed. And then a lot of the material, in the absence of storms, made it back into the project area 3 months post-placement. And then over time, it's kind of stabilized with this about 2,500 cubic yards in the southern section. So about 700 feet of the southern project area has advanced seaward. The rest has remained relatively stable. What's next? As I said before, we also did drone flights. We created digital service models for our three-dimensional volumetric calculations. But just to give you an idea what the project looked like before and after completion, this is November 2020 all the way to the left, and 12 months is December 2021. So you can see here, the majority of this material was placed along this near shore here, and 3 months following the project, you can still see some of the sediment accumulation along the shoreline here, but the majority of the material had formed into a nearshore bar, and it's actually starting to weld to the beach here. And then by June, even more sand had actually started to weld and build vertically upward on the beach face. And then by December, a lot of that had actually leveled off. So we have a much shallower slope offshore. So even though the emergent bar it's hard to see, this is also a higher tide. The majority of material that was in this location remained in this area along the beach profile within the nearshore berm area. So what we're seeing is out of the entire project area, offshore sediment moves pretty rapidly with regards to northeast storm events. But on the beach face itself, it remains relatively stable. It's just eroding a little bit on the landward side, cross shore. During the active placement itself, our turbidity monitoring sensors showed significantly higher NTU values prior to the actual project, prior to the actual placement of the material in the nearshore. So there was relatively high suspended solid concentrations, about 400 milligrams per liter in the immediate project area near the discharge pipe, but it sharply dropped off to the ambient conditions about within 300 feet of the project. The preliminary data show that there's a longshore sediment transport to the south along the beach. And based on even between the 6 month and the 12 month, about 42% of the material placed in the near shore has remained. But across the entire mapped project area, there was actually a volume loss over 12 months, about 7,100 cubic yards. That we witnessed similar losses actually between the before dredge and after dredge to the offshore. So no big surprises there over the winter time. There was a seaward shoreline movement and accretion occurred in the southern 715 feet of the project area over the survey period. But what our results are showing is that different configurations, perhaps feeder beaches in the future, may provide longer duration shoreline restoration or seaward advancement of the shoreline and less losses to the offshore. This is part of the preliminary model we have. Just showing you the velocities along this shoreline here, just giving you an idea of what it looks like. So we're using this model to actually real-time remodel the active placement to see where and compare that with the active plumes during the active placement, in addition to long-term, the morphological response of the nearshore. And I think that's it, Adriana.
Great. Thank you, Dan.
Thanks, guys.
I'm going to stop sharing, and Joe, the floor is yours.
Okay, thanks. And we haven't talked about the timing much, but yeah, like this project just happened, a little over a year ago. It's really cool to, just get the chance to round up everything we have so far as monitoring results and share what we have. But yeah, the story is ongoing as we continue to collect data. Just want to give you a perspective on where we are. Good luck points toward the upper end of the Barnegat Bay. And here's that tidal range that Scott mentioned. And it's worth mentioning, like in New Jersey, I don't think there's been a placement on the marsh in a microtidal area. Everywhere else, I think, is at least a meter of tidal range. So it's a unique setting. And so, we've talked about monitoring and yeah, we have really thorough monitoring that went on, before the project and continues after, led by Yanni Lascaris and Noel Turner and carried on by Amanda Archer and Taylor Schmidt. And where we work at a couple sites, a couple refuges, and encompass these metrics: water levels, surface elevation tables, vegetation and bird surveys. I won't be able to get to all of it today, but it's there and part of that monitoring plan that Genevieve mentioned. And we've got our project area that we've already identified, bounded by that road, and then the control site just outside the road. And as far as Genevieve talked a lot about the purpose and need of projects, and at least the need seems to be there in marshes like these, where we have these ponds forming between ditches. We've coined the term waffle pools for this, and it's a phenomenon that I've worked on to try to understand a little bit better, like where these things occur and why they occur, and then what interventions are best to address them. And so there's this paper if you want to learn more, but we kind of looked at patterns across the Northeast and found hotspots, and the hotspots are basically in really microtidal areas like this one. So we have some pooling, forming outside that road area, but it's even worse inside the road, because the other thing we found is that tidal restrictions can also induce this waffle ponding thing. Tidal restrictions generally reduce tidal range and create microtidal conditions wherever you might be. So we got double the problem in this area. So we've got, totally impounded by this road and an old railroad track with just a couple of culverts moving material. And the refuge worked hard to try to increase the size of these culverts, but infrastructure limitations on this road really prevented getting a lot more water in there. And so that's what we're looking at. So those blue, zigzags look like it's a huge tidal range. That's only 8 inches. That's the background level, more or less. And so it's about halved in that interior area. So what that means for a restoration project and trying to hit a target elevation, it's a razor's edge you're trying to work on. So really challenging situation, but really important because these marshes are, sometimes people talk about, oh, we should prioritize, and maybe there's some marshes that we just write off, but Barnegat Bay marshes, it's really tough to say write them off, because they play such a big role in just managing the whole hydrodynamic regime in the entire bay. So it's the stakes are high for even these beleaguered marshes. And if you're follow marsh restoration in New England, a lot of work has been done in these waffle type marshes using runnels to try to drain the ponds and then create conditions where veg can grow again. But again, because we're on that razor's edge of a tiny range in which vegetation can grow, even if you drain these ponds, the vegetation is not going to grow back. And in this area, it's so close to the upland, and so geologically recently was was an upland. There's a lot of sand under there. So the sand, I think, helps these ponds drain. Typically, they might not drain in other types of waffle ponded marshes. And this is the other reason these marshes are important to focus on, because they're disproportionately used by species of concern like salt marsh sparrow, as well as black rail. We've got some credible reports of black rail at this site as well, so which was recently put on the endangered species list. So for the Fish and Wildlife Service, another big motivation to figure out how to fix these marshes. Again, these birds are attracted to these places because they are, at least historically, infrequently flooded. But as Scott mentioned, we've done a lot of interventions to mess around with the hydrology, and the more you mess around in microtidal marshes, the more dramatic the impact is, because they're truly less resilient because of that narrower tidal range and narrower range for which vegetation can grow. This is the project area, and you can see the dotted lines are ditches that were intended to be filled with material along with the pools in between the ditches, and that's generally understood that these marshes have more channels than they need, given the small amount of water that needs to move in and out of them, and so that's the idea there. Okay, so just getting into what we're seeing as far as elevations post placement and vegetation response and things like that. We'll get into that. That's our amphibious excavator and some of that 10,000 feet of pipe that Scott was talking about. And so the area, given the material available, the area within the permitted area was about 5 acres or so. And here it is, I think, early June on a satellite image, and you can see some of the material kind of showing up in that area. And what I've got here are little lines we did with RTK GPS to get some pre-placement elevations. And then we have LiDAR data that DOT collected to get some post-placement elevations. And just to zoom in, this is before and after just last winter, and so you can see some of the vehicle patterns and areas of sand and mud. All right, so we'll just superimpose some of that LiDAR, and this is a personal achievement for me because I've never messed around with raw LiDAR data, and we got something that looks pretty decent, and we have some validation data with RTK GPS, but yeah, so we got this sculpted varying elevation landscape. And if we just flip this little line into a profile, we can see the patterns of filling ditches, those ditches that I pointed out, and then the interpool areas. Again, shooting for that 0.7 foot target elevation, which is about where Peyton's Spartina Peyton starts growing at this particular site. There's a look at one of the ditches that was filled, and it's some of these areas are somewhat filled, somewhat not filled. Some of these areas I brought mosquito control folks to the site, and this is the kind of thing they look for as mosquito habitat. These very shallow areas that might not have fish, but no concerns so far. They checked it a few times last year. And here's our elevation after placement, and looks pretty good to me. I mean, it's a bell curve centered right on that target elevation, so pretty nice. And so the dotted lines are kind of the site at the site where Spartina alterniflora and Spartina Peyton's grows, and this is just tenths of feet. Probably 0.3 of a foot is the range at which these plants are growing before you get into upland or before you get into open water. But yeah, so some of the elevations went a little higher, like Scott was saying, with the sand component, which there was a little bit of sand that came in with the silt, and you get little lumps. And I was shocked to see this, but almost immediately, Phragmites found a way onto these little lumps that they're a little above the range of the Spartina Peyton. So we'll keep an eye on that and adaptively manage the frag. But I was pretty impressed by the dispersal ability of this plant. And then, beyond the plate, where we wanted the material to go, it did go into some of the ditches that weren't planned to be filled like that, kind of a conduit for water through the culverts. And so we did some measurements of those just to see how they change over time. But some of these ditches, so if you see here, this is one of the main culverts and how water gets into the site. And we just, it's just an example of measurements around here. So, significant accumulation of material in these ditches, which, sort of affects the flooding regime in the project area. And it's interesting because, when you add material to this site, it actually changes the amount of water volume that the site can hold. So it's a way, adding material is a way to manage that water balance. You need smaller culverts if you have more material in the site because you're allowing less water in. I don't know if that makes sense, but what I'm saying is these altered drainage patterns may not necessarily be a bad thing in the long run, but right now what we've got is we've got some silt. This is one culvert here. We've got some siltation in these ditches that prevents one area of the site from draining fully. It just doesn't have a conduit at this point. And then we have a main flow path here. But overall, this may allow less water in overall. So there's a lot of the hydrology story here that we still have to tease apart and understand better. But from what I can, gather, like the main flow path is here. So as the tide's rising and the biggest, push of water is in here south and then kind of wraps around the backside. And then as the tide gets higher and reaches the elevation that these ditch bottoms are at, then it starts moving into this part of the site. We still have issues with like when a lot of water comes in, we have a nor'easter and water's pushed into the north part of the bay. You get water backed up and it takes some time to drain out, but it's just the way this strange altered site is. That's a look at one of these silted in ditches. But to get into the last part of the talk, the vegetation response, it was really, really interesting. After just one growing season, just lots going on. Something I've started to notice is that in the early spring, you get this like bloom of germinating Spartina alterniflora seeds in just about all kinds of places, even places where you wouldn't expect it to grow. But the site benefited from this bloom that really held on. So there was a lot of natural colonization and revegetation just in the first season. You can see how it's progressing here in mid-season. In addition to that, just to try to add value and learning from this experience, I did some test plantings and some little site treatments, little plots with different treatments, all kind of geared toward dry conditions, anticipating dry conditions at the site because we're raising the elevation. And we heard in the last session of this webinar series, the concerns about material drying out and becoming acidic. So that's something I had a real eye on. And so we were measuring pH and moisture at these plots. And then had these treatments kind of designed to like retain moisture really. This jute fabric covering. And then I did we did some hay mixed into the sediment with the jute fabric covering with the idea of like creating more of a connectivity between that, lens of silt and the, peaty material below, giving a moisture reservoir and a conduit for moisture to move up and down. That was the idea anyway. And then even I went even a step further and was playing around with drip irrigation, gravity drip irrigation. And things were, at certain parts of the summer, you can see there's some dry cracked mud, and David Steinman came out one day and kind of helped me see the world through his eyes, and we're starting to see some rustiness, which could be some oxidation, but then things got wet again. We actually had I guess a mostly average summer for rain, but then had an extra 2 inches in July. So I think that partially helped things kind of the plants hold on pretty well. And then the other thing I think might be happening is those silted in ditches are helping like hold you know, like the water table, kind of hold the water table higher in our placement area, and that may have also, you know, been in favor of these plants. That's why I'm not, you know, exactly sure those silted ditches are you know, there's pros and cons, I think. The time will tell. But yeah, the site was pretty wet a lot of the summer, as you can see here, but things were progressing nicely. This is plots with our alternative flora plantings, and then here you can see some of the Peytons. I think that's Peytons there, doing pretty well. So again, we had a control, we had a jute fabric cover, and then we had a jute and hay treatment. So just to finish up by showing you those results, we put a bunch of plots up there, and you know, some were right near the edge where there was already existing vegetation, and then some in the center. And here's our results. So Spartina Peytons, you know, was off to the races, especially at the edges. But yeah, I think the general like wet conditions kind of caught up by midsummer, and we started to see a decline in Spartina Peytons. But yeah, there's still quite a few of them out there, you know, relatively speaking, but didn't do quite as well as Spartina alterniflora, which did well regardless of where it was in the center or the edge. And then overall, we just saw a lot of like colonization of our plots. We're doing stem counts, and it became kind of overwhelming because we had so much alterniflora coming in, both from rhizomes at the edge and then from seed, you know, growing into pretty big plants. Back to Peyton's, just looking at our little plots, our control, bare mud, fared the worst. And then our treatments, progressively, the Peytons did better. And so that's interesting. I don't exactly, you know, have an explanation for that, because this was intended to deal with dry conditions, not wet conditions, but maybe you did something to buffer the wet conditions as well, you know, absorb moisture or drain better with the, you know, with that hay in the matrix. But yeah, something going on there, which is encouraging to me. Like, you know, this whole idea is, you know, with these kinds of treatments is like, okay, well, if we really want to invest in marsh restoration and we're, you know, really serious about creating like high marsh, for example, like then maybe we can, you know, take that next step and do, you know, extra work and extra costs of site prep, you know, to just favor these things to establish more quickly. That's the, you know, general idea, you know, behind these little plots. Not much going on with the plots with alternative flora, really. They did pretty well in all three treatments. And then, yeah, finally, you know, being out there this winter, and we had a pretty icy and snowy winter for these parts, and there was potentially one other benefit of these, you know, erosion, basically erosion control fabric, that some of the control plots, the plugs got scoured out by, I guess, ice moving around the site or something like that. But yeah, I mean, like this was, here's a, you know, to end, you know, here's a view of the core of the placement area, and you can see that's all colonized, or most of it is colonized Spartina alterniflora. And so, yeah, for now, I think we'll just, you know, keep an eye on the progress of this vegetation. You know, things are going relatively well. Like the goal is to revegetate these sites. So far, so good on that point. And then just try to understand this hydrology at the site a little bit better and consider interventions, you know, and say the trajectory of vegetation takes a turn for the worse or something. And then, of course, we got plenty of permitted areas still available for restoration. So exploring opportunities to keep going, you know, to keep restoring the site and keep learning from this site.